I am focusing on the scikit-learn's LeavePGroupsOut function, which is a specific type of cross-validation. It's designed to work with datasets that are grouped, leaving out entire groups during training and testing. We're tackling a problem involving this LeavePGroupsOut function. It'll be figuring out how many different ways it can split your data for cross-validation. Let's get started. The context describes a dataset divided into 4 groups. We want to leave out 2 groups at a time for testing, using the remaining 2 for training. The question is, how many such splits are possible? This is one of the possible answers to the number of splits produced by the cross-validation technique. The correct one. In fact, this is a wrong answer. It's tempting to think it's related to the total number of samples. But that's not how LeavePGroupsOut works. It focuses on groups, not individual samples. Another incorrect answer. This would be correct only if we were leaving out 1 group at a time, not 2. This answer is also wrong. It doesn't match any logical way of dividing the groups for cross-validation. To make sure we understand the situation fully, we note that the dataset has 12 samples, organized into 4 groups of 3 samples each. This clarifies how the data is structured: 12 total samples, separated into 4 distinct groups, with 3 samples in each group. This is the calculation needed to find the number of ways to choose 2 groups out of 4. It's a combinations calculation. In simpler terms, 4 3 2 1 2 1 2 1 6. There are 6 ways to choose 2 groups out of 4. This is a type of cross-validation where I leave out p groups of samples when I train my model. I use the remaining samples to train and then test on the p groups I initially left out. It's a great method to avoid overfitting and get a more robust evaluation of my model's performance. This is the problem statement given a dataset with 12 samples, divided into 4 groups, 3 samples each, and using LeavePGroupsOut with P2, meaning I leave out 2 groups at a time. How many different ways can I do this? This is the total number of individual data points I have in my dataset. This number is a consequence of having 4 groups with 3 samples in each group. 4 groups, 3 samples, group 12 samples. Each of the 4 groups contains exactly 3 samples. This is an important detail for understanding how many combinations are possible when leaving out groups. My dataset is divided into 4 distinct groups. These groups might represent different categories, locations, or any other grouping relevant to my analysis. The key is that the samples within a group share some characteristic. This fact is implied from the previous details provided about groups. I can derive this by multiplying the number of groups 4 by the number of samples per group 3. 4, 3, 1, 2 audio src https translate.google.com translateds IEUTF-8Q. That's it, 2CA folks. TLN client TWOB. C data. That's it, folks. Audio. I'll explain the formula. Say as interpret as characters and say as. Say as interpret as characters p say as. Say as interpret as characters and say as. Say as interpret as characters p say as. This formula calculates how many ways you can choose say as interpret as characters p say as items from a set of say as interpret as characters and say as items. The means factorial, multiplying all whole numbers from 1 to that number. For example, if I have 4 groups say as interpret as characters and say as 4 and want to leave out 2 say as interpret as characters p say as 2, I use 4, 2, 2, 6 ways. This is crucial for calculating the number of splits in LeavePGroupsOut cross-validation. This is the mathematical expression of the combinations formula. I calculate the number of ways to choose say as interpret as characters p say as groups out of say as interpret as characters and say as total groups. It's the core of determining how many cross-validation splits I'll have. Here, I define the variables in the combinations formula. Say as interpret as characters and say as represents the total number of groups in the dataset. And say as interpret as characters p say as represents the number of groups that will be left out in each cross-validation fold. This is fundamental to understanding and applying the formula. I am using LeavePGroupsOut, a scikit-learn function for cross-validation. It's a clever way to split your data into training and testing sets when you have groups of related samples. Imagine you are testing different fertilizer on plants, with each pot representing a group. LeavePGroupsOut lets you systematically leave out some groups for testing while using others for training. This is the core question. We have 4 groups of samples, and I want to leave out 2 groups in each split for testing. The question is how many different ways I can do this. This answer is wrong. It confuses the number of samples with the number of ways to choose groups. I am not interested in the total number of samples, but in the number of ways I can select 2 groups out of 4 to leave out. Incorrect. This would be true if I only left out one group P1 at a time. But I am leaving out 2 groups P2. Wrong. There's no mathematical way to reach 3 splits with 4 groups and leaving out 2 in each iteration. I am using combinations to solve this. The exclamation marks mean factorials multiplying a number by all smaller whole numbers. 4 is 4, 3, 2, 1, 2, 4. 2 is 2, 1, 2. This formula calculates the number of ways to choose 2 groups from 4 groups without worrying about the order. The calculation shows there are 6 different ways to make those splits. We're figuring out how many times scikit-learn's LeavePGroupsOut will split your data for cross-validation. Think of it like repeatedly testing different combinations of your data. Break time 300 milliseconds. You have 12 data points, neatly organized into 4 groups of 3. Break time 300 milliseconds. This is how the algorithm will see your data. The P in LeavePGroupsOut P2 means we'll leave out 2 groups each time we split the data for testing. Break time 300 milliseconds. We'll use the remaining groups for training. The core question is how many different ways can I choose 2 groups out of 4 to leave out for testing? Break time 300 milliseconds. That's what we're solving. This is the correct answer. We'll find out why. Break time 300 milliseconds. Incorrect. This answer mistakenly uses the total number of samples instead of the number of groups. Incorrect. This would be correct only if we left out only one group at a time P1. Incorrect. This number doesn't fit the calculation for choosing groups from the available set. This is a type of cross-validation, a technique to evaluate machine learning models. Break time 200 ms specifically. It's about systematically leaving out groups of data points when training a model to test the model's ability to generalize to unseen data. Break time 300 milliseconds. The LeavePGroupsOut part means I am leaving out p number of groups of data points at a time. This is a multiple choice question testing your understanding of how the LeavePGroupsOut function in scikit-learn, a popular Python machine learning library, works. Break time 200 milliseconds. It asks you to calculate how many different ways you can divide a dataset into training and testing sets using the LeavePGroupsOut method with a specific number of groups in a specific number of groups to leave out. I am setting up a cross-validation scenario using scikit-learn's LeavePGroupsOut. Break time 200 milliseconds. I have a data set with 12 samples divided into 4 groups, 3 samples per group. Break time 200 milliseconds. I want to perform LeavePGroupsOut cross-validation, where I leave out P2 groups at a time. Break time 200 milliseconds. The question is, how many different ways can I do this? This is one of the possible answers to the question of how many splits the LeavePGroupsOut function will create. Break time 200 MSIT represents a specific calculation of the number of possible ways to leave out 2 groups from a set of 4. This is an incorrect answer. Break time 200 MSIT incorrectly uses the total number of samples rather than the number of groups in calculating the possible splits. This is another incorrect answer. Break time 200 milliseconds. It represents an incorrect calculation based on leaving out one group at a time P1 rather than 2 P2. This is also incorrect and represents an incorrect calculation of the number of possible ways to divide the dataset in this specific configuration. Describes the structure of the dataset. I have 12 data points, organized into 4 distinct groups, with each group containing 3 data points. Break time 200 milliseconds. This is key information for calculating the number of cross-validation splits. This suggests a diagram could effectively represent the different ways the dataset can be split for cross-validation using the LeavePGroupsOut method.